Hi everyone, and thank you for joining us this evening. My name's Lizzie, and for those of you who I haven't spoken with, I am the Senior Heat Pump Specialist here at Good Energy. I look after the sales team, so I'm sure you've spoken to some of my colleagues, Harry, Uday, or even met some of the survey team, so Cameron and Tom. And throughout your journey with your heat pump with us. So to give you a bit more information about Good Energy, if you don't know, so we were founded about 25 years ago, and we wanted to host this webinar for customers who are already in the journey with us to provide a bit more information on how heat pumps work. Not only that, also what to expect on installation and what life is actually like having a heat pump. So to give you a bit more background on us and our heat pump journey so far, so we have commissioned 337 heat pumps. We have 4.8 stars on Which Trusted Trader, and we are a full member of the Heat Pump Association, which we are extremely proud of. And not only that, we are very proud to be part of B Corp community, which makes us the only B Corp certified home energy supplier in the UK. Um, what I'm going to do, I'm going to pass you through or start for my colleagues for more information and to go through the webinar in a bit more detail. I'm going to pass you through to my colleagues, Max and Ben, who both actually have heat pumps installed in their home. So we thought not only would it be really good and useful to be speaking to the operational side of the business and the installation side, we thought it'd be really important for you guys to actually be able to speak to people that actually have lived and breathed experience with heat pumps in their homes. So without further ado, if I hand over to Ben first.
Yeah, so hi everyone. My name is Ben. I'm the installation manager here at Good Energy. I've been a heating engineer for coming up 20 years this year, which seems like an extremely long time now I'm saying it. 11 years of that has been working with heat pumps, installing heat pumps or maintaining heat pumps and renewable technology. I'm, like Lizzie said, I'm also the proud owner of one of our Midea heat pumps. I've had it now for, I want to say 3 years. And, I think the best thing that I've had with this heat pump is my house is now just a constant 21 degrees throughout, all the winter months or the summer months. Whereas with my gas boiler, which I had before, it was sort of peaks and troughs. So it's just a lot more comfortable to live with it. Max?
Yeah, good evening, everyone. So yeah, I'm Max. I'm the operations director, looking after the heat team here at Good Energy. So that is the design process, the technical side of it, the after sales customer care is also in my team, as well as Ben and the installation team as well. So I'll just start by saying any questions that you guys submit at the end, we'll do our best to get through them as much as we can. We've got a list of questions that you had at the start there, but you can drop them in at any time and ask anything about your journey or how we kind of approach things here at Good Energy. But just a bit about me. So I came from the engineering side, if you like. So I was at a company called Valent that make boilers, heat pumps, things like that for just a bit over 10 years on heating design, on commercial heating boilers, and then renewable towards kind of the back end the last 3 or 4 years at Valent there. Done quite a few roles in heat pump space in terms of looking after survey, technical teams, technical support myself before taking over the team kind of in the last 2 years or so. Very much like Ben, I also have a heat pump. I've got solar here as well as a battery, and I'm actually sat down in my wife's office at the moment because my 2 kids, my wife, are upstairs getting ready for bed, having a bath, my 2 young kids. So we get through plenty of hot water, all that sort of stuff. So again, any questions on living with a heat pump, what they're like with a family, or how you kind of have to adapt your life or not to have a heat pump, then by all means chuck the questions at us and we'll do what we can to answer them. But I think before that, we've got a few slides just to talk you through a few of the aspects of how heat pumps work, what they do, explain a bit about us as Good Energy, and a bit about our installation work as well. So yeah, I think straight onto the first one, please. So I mean, I can take this one, how heat pumps work. Again, so it's a what would appear to be a new technology, certainly for us in this country. Heat pumps have been around for a long time, actually. I think I think the first heat pumps were used in heating way before kind of the first combi gas boilers were even available. If you ever go to a supermarket, Sainsbury's, Tesco, anything like that, you go to a hospital, I can almost guarantee you it's been heated by a heat pump and not by gas boilers. The chillers that they use to cool food, even the fridge in your house, that's a heat pump. Cars use heat pumps to generate heat. It in and of itself isn't a new technology. We in this country are quite new to using it to heat our properties and our hot water, but again, they've been used in Europe and all over the world, the US, places like that, for decades for heating. So they seem quite complex. You know, how is something over 100% efficient? How is it creating this heat from basically a fan in a box, from what you see in the picture there? So it's all down to this kind of fluid inside the heat pump. It's called a working fluid. And basically, all it is, without getting too technical, it's just something that boils at an extremely low temperature. So the heat pump in the picture there, it uses a refrigerant called R32. There's other sorts of refrigerants available, but basically it boils at minus 52 degrees. And why that's significant is this kind of cycle you can see on the screen there. You've got the fan, it draws air from outside across this kind of these fins in the back of the heat pump. Inside those fins is this liquid, this R32 refrigerant. Basically, it boils that, it increases the size of it, it goes through the cycle to something called a compressor, kind of similar to putting your thumb over a bike pump and going really fast. It compresses the gas, and in doing so, it generates big amounts of heat. And then you've got something called a condenser, which just runs water across that kind of increased temperature surface and heats up the water that will be passed through your property into your radiators and into your hot water cylinder to heat. So it seems very complex, but the way it produces more energy than you put into it is basically, it isn't creating energy from nothing. It's just allowing us to move energy from the air outside through this refrigerant into your property. And the energy that we've actually got to pay for to make the heat pump work is for that compressor and the fan to work. So basically every 1 unit of energy you're putting into that heat pump to make this cycle work, you're also drawing in 2 or 3 units of energy from the air at the same time. So it basically works by boiling something, pressing it together, creating heat in doing so, and passing that into your house. So again, there's a lot of good blogs and things like that on our website if you wanted to read more into this. And I think there's quite a few podcasts that Lizzie and myself and a few others have been on that describes this as well. But again, just to keep it really simple, it just moves heat from one place to another, being the outside air, into your house. Ben, do you want to take this one?
Yeah, so all of our designs, they're all done in-house. We've got our own in-house design team. After the surveyors have come to your home, they pass all that information over to this team, and each of these designs are done, you know, tailor-made to your home. On average, you know, our heat pumps are 360% efficient. You know, we can get a lot higher than that. Mine personally is running at about 450% efficient. I know that Max's is up closer to 500%. And the reason that we use this as a sort of average is we're doing these designs and these installations bespoke to people's houses. So if we really want to get into the nitty gritty of it and give you an extremely low flow temperature so that your efficiency can be a lot higher, then we can do that. But, you know, we're taking a mean average across all the installations that we've done. Gas boilers, they waste a lot of the energy that they use to run. You know, when you're going down the street on a cold morning and you see all that plume of smoke, plume of condensation and steam coming out of the flues, that's lost energy. All of that heat just being dispersed through the flue. So we say that an average boiler is somewhere around 90 to 95% efficient. So you can see that the efficiency of a heat pump is much higher. Also, we're trying to reduce, obviously, the amount of carbon that's being released, and also try and get your energy bills as low as possible as well.
Thanks, Ben. It's one good thing to call out here as well is the 360 average across here. Something that we do that a lot of other energy companies don't is we work with customers with a big variety of budgets. Some can, you know, some want to make all the changes to the radiators and get that temperature as low as possible, and therefore increase the efficiency. Hence Ben's, mine up near the 500% efficiency. But the other side of that is we have customers who maybe want to get the heat pump in as high a temperature as possible, and then over time invest in the radiators to bring that efficiency up over time. So we're very flexible in how we install, and our kind of aftercare and our monitoring allows us to work with customers for years after the install to continually improve it and to recommend changes. We might only change 2 radiators initially on your installation, but then next year you might want to change 2 more. That might allow us to drop that flow temperature by 5 degrees and therefore increase your efficiency up to 50%. So it's something that we always work with our customers with, and we're always in communication, and it's very much part of our aftercare process that we will continue to work with customers to help improve that and make their installation better year upon year.
And you just reminded me of something really good actually there, Max, as well. When I actually installed my heat pump in my property, I'd moved in, didn't really know the house or the system that I had too well, only having been in here a few months. The cylinder looked fairly new. Obviously, being from a plumbing background, I knew sort of roughly what year it was put in. So I decided to put my heat pump in on a traditional sort of boiler cylinder. I ran it on that for 2 years, and finally when it gave up sort of 18 months ago, then I changed it over. So we didn't have to do everything all at once. We have specific cylinders that are made for heat pumps. They have bigger coils in them so that the surface area to transfer heat over into your hot water is much greater, but it's not something that definitely has to be done at that point. If you want to sort of just work your way into having a heat pump, there's certain changes that we can make along the way.
So in terms of the heat pumps that we install, there's essentially there's 2 types of the Midea or Midea, however you want to pronounce it, heat pumps that we offer. And other than the appearance, how they work is essentially the same. But the difference here is, I talked earlier about that kind of refrigerant, that fluid that's inside the 2 heat pumps. And the difference between these 2 units is that refrigerant gas is different. So you can see the numbers, which probably mean nothing to most people, which is R32 and R290. That is just the working fluid that's inside that heat pump. In terms of efficiencies and transfer and stuff, they're fairly similar. The difference between R290 and R32 is that the R290 on the right can get a lot hotter in terms of temperature than the R32 unit. So I'll just run through a few of the points that we've got down here, and then I'll explain a bit more on that. But in terms of cost and what the units kind of cost out of the box and how we install them, the R32 units are cheaper than the R290. The reason is R290, another word for that is propane. That's the gas that's in there, and you have to have kind of a lot of internal protection for the heat pump to run this refrigerant. So there's more components and equipment in there, so the cost is essentially higher. Both Ben and I are running R32 units at the moment, but we have got R290 units out there as well. When it comes to the temperature, the flow temperature coming out of it, this is the temperature essentially that we would heat your radiators to heat your property. The R32 units, they can actually do up to 65, but they are, I guess, certified and tested up to 55 Celsius, whereas the R290 units can go up to 75 Celsius in terms of the temperature coming out of your radiator. So definitely into that boiler temperature territory. It is worth pointing out, the hotter that you run a heat pump, the less efficient it is, therefore the more it will cost you to run. So these kind of ones on the right, they are also known as high temperature heat pumps. They are generally designed at higher temperature for harder to treat properties, or maybe somebody who can't change all of their cylinder and radiators and they couldn't feasibly reach a comfort level using 55 degrees. We might then recommend one of these to go higher. It's worth pointing out, we always try to design for as efficient an install as we can, which would always be a lower temperature, but the R290 can go up to 75 if we need it to. In terms of running costs there, I mentioned that pretty much comes down to how you run it. If you have both these heat pumps and they were both running at the same flow temperature, the running cost would be pretty much bang on the same for either. It's not really too much of a difference. It's just if you run the R290 unit at a much higher flow temperature, you would probably see the running costs increased compared to that of the R32 at a lower temperature. Where the R290 does have benefits is that Ben mentioned there about keeping his old boiler cylinder, for example. The way a cylinder works is essentially there's a little coil that allows you to pass water through the hot water cylinder. So the water in your cylinder doesn't actually pass through the heat pump. It's just got a coil inside which would allow heat to move from the heat pump's water to the cylinder. In heat pump specific cylinders, this coil is much bigger, so there's a much bigger surface area to transfer heat. We need that usually because we're doing flow temperatures about 55 or 60 degrees to get your hot water cylinder to kind of 50 degrees Celsius. You can do higher temperatures up to 75 in that R290 unit. So basically you could do with a lower surface area in that cylinder. Therefore, you could keep a boiler cylinder, essentially is what that's saying. Now, that said, again, Ben's just mentioned it there. He did have a boiler cylinder running on his R32 unit, working absolutely fine. It's just that your hot water might take a little bit longer to heat up, maybe an hour instead of 45 minutes or something, if it was going from absolute cold to warm. But again, you can make decisions like that based on a higher temperature that the R290 gives you. The first kind of real difference with these units is where you can put them. R32, there's no kind of real protections with that. You can put it anywhere outside your property. We just need kind of 300 millimeters of clearance to the back and the left and right, and a meter in front so that it can kind of blow the colder air away from it. The R290 unit, because it's got that propane in it, the regulations at the moment say that it's got to be, I believe, a meter from any openable door and window. And you've got to have some other clearances around it as well. So basically, because it's that propane. Now, that's a regulation. What I always say to everyone is I wouldn't necessarily let that be a concern or a worry, because this is the same stuff that, I'm blurred at the moment, but my barbecue's just outside, right outside the window. The 5 kilo cylinder my barbecue's using is propane. It's exactly the same stuff. The difference is that's 5 kilograms and there's less than a kilogram of it in this heat pump. But the building regulations have you move that heat pump from a window and door at least a meter before you can install it. So that's a point to note there. And then the last call out is boiler upgrade scheme. Both these heat pumps are eligible for the boiler upgrade scheme. You can get the £7,500 grant on there. The call out for the R290 is that you have to have a minimum efficiency of 280%. What I would say is this R290 unit, even if you install it at 65 degrees Celsius, so that's kind of the upper limit of heating temperature we'd usually put, it's still more efficient than 280%. So there's no scenario where we could offer you one of these heat pumps where it wouldn't be eligible for the boiler upgrade scheme under efficiency alone. It would only it would just be based on kind of normal property parameters. But again, it's something that we can help you with throughout the journey. Oh, anything to add on that, Ben?
No, nailed it. Cheers. I'll take this one. So yeah, these are some not so recent now, but some cylinders that we've installed in the past. I think it's worth pointing out that we do get some very weird and wonderful shaped houses. They're not all just your cookie cutter installs. It would be nice just to have a nice estate and everyone decide that they want heat pumps all at once, and then by the time we've gone through a certain amount of houses, it would just be like clockwork. But we go into Victorian properties that weren't designed to have airing cupboards and don't have the space for it. We can fit cylinders in. We've even done them in bespoke outhouses before on the outside of a property that are pre-insulated. We can put cylinders up into loft spaces. So we're quite good now at getting heat pumps and cylinders into buildings that just weren't quite designed for them. I think it's a perfect opportunity as well. We do get a lot of questions asking, what does a typical install look like? How long does it take? Who's going to be in my house? And sort of what upheaval is it going to cause? I think, the average installation that we would do here that would consist of, the removal of a gas boiler, the installation of a cylinder, and perhaps 3 or 4 radiator upgrades, probably last between 5 and 6 days. That would be for a qualified heating engineer, qualified electrician for most of those days, probably not all of them, but most of them, and then an apprentice or a trainee or a plumbing technician, someone that's just coming into their sort of heat pump experience but have still got experience with plumbing. On day one, most of the day is taken discussing throughout the team on the pipe runs with the customer, making sure that they're okay with the design, taking receipt of goods, and sort of starting to plan that installation. Day 2, probably siting the heat pump, laying the pipe work from the heat pump to the cylinder location, and starting to put the infrastructure in. What we really want to do is keep the downtime and the upheaval to a minimum for you guys. So we don't want to leave you for extended periods without hot water or without electric. So the guys are really good at discussing with you when would be good times to do the switch over for your electric, for example. I think the average sort of time that customers don't have electric for is probably, around the hour mark. The guys don't come in and turn it off for the entire installation. They'll do all their work, and then when they've got to make that final connection, then they'll let you know, make sure that it's okay with you, and then they do that switch over. The same with the cylinder. So sort of midway through your installation, the guys will sort of warn you, tomorrow's going to be the day where we're going to switch your cylinder over, or we're going to connect your cylinder to your system if you had a combination boiler. And they'll do that in one day, or try to aim to do that in one day. So they'll start fresh in the morning, and then hopefully have you with the hot water back up and running. So that what we aim to do is make sure that you don't have hot water overnight. You don't go without hot water overnight even. That's not the same for every single install. It really does depend on the infrastructure that you've already got, the shape and size of your house. There's lots of variable factors, but we really do aim to make sure that you don't have one single night without your hot water not being on. I can guarantee you now that we wouldn't leave you without any running water whatsoever. Never have we even come close to that. So, that's something to consider. And then those last couple of days, sort of day 4, is going to be running through, getting those radiators installed onto the wall, giving the system a good clean and flush, and then the final day is going to be the commissioning. And most importantly is that handover to you as the homeowner. You've just spent what's a considerable amount of money on a heating system that you've never seen before. So the last thing that we want to do is install it and run away. We want to make sure that you know how to use it 100%, and make sure that you're happy with the installation before we go off and leave you to enjoy. That's it.
Thanks, Ben. So I mentioned earlier on the slide about the 2 media heat pumps and radiator sizing and how that's different. I think all of you guys that have been invited to join this call tonight have gone through the survey process, and I believe have had a proposal in there. Most of you notice that there'll probably be some recommendations for radiator changes, or it will talk about the temperature. I've mentioned it a few times now, the water that we're putting through your radiator. Something that is just worth discussing or spending a few minutes explaining here is why we look at changing radiator sizing and things like that. You may have had several boilers over the decades or the years, and there's never really a talk of, well, I need to change or upgrade my radiator or the sizing or anything like that. Decarbonising heat and using a heat pump, the best and the most steady way to use a heat pump and to get the absolute most for what you're paying for the energy and the efficiency out of the unit is to just kind of leave heating on low and slow in the background. And doing that, we need to make sure that we've got a really good surface area to give heat into your property. I think our average is 3, maybe 4 radiators per job that we change. So we're not talking all the radiators, but something Ben will probably attest to here, spending years as a gas engineer before moving into renewables and things like that, is for years, heating engineers in the heating industry, they'll fit a boiler. They don't generally size a radiator for what the room needs. It'll just be sized to fit under the window that's there, or it'll just be, what looks good in that corner. Whereas what the heating industry is doing at the moment with heat pumps is getting a lot more into the numbers and the calculations, and really figuring out, okay, how much heat does this room lose per hour? How much heat do we have to put back into it to maintain the temperature we want or increase the temperature? And to do that, we've basically got to calculate what size radiator a room needs. So what this graph basically shows you is, if there's a radiator that's sized at 60 degrees or above, we would consider this kind of the least efficient heating delivery mechanism. You can see there on the left, there's the stars going up. The lower you get in terms of temperature you can put through the radiators, the higher the stars. So in this instance, it's showing you how efficient that is. And across the bottom, you can see some random looking numbers, which is called an oversize factor. So what this essentially means is, if you've got a radiator that's working for your house and it's keeping it at the temperature that you want in your living room, based on whatever your boiler's kicking out there, let's say it's 60 degrees. If we wanted to get your heating system all the way down to 35 degrees for a perfectly sized radiator in that room, you'd need to upsize that radiator 6.8 times. So essentially that's saying you need underfloor in that room. Now, like I said, radiators have historically not been sized for rooms. So what we find is generally a lot of them are actually fine. They're bigger than are required. They fit under a window. They're absolutely fine for that. But we're just kind of showing you this graph just to kind of explain why you might see radiators on your quote. And our team of designers, Alex and the team that look after the designs that go on and the heat loss calculations, they are absolutely looking at the needs of each individual room in your property and figuring out, well, what size do I need to make this radiator to work for the temperature that the customers discuss with us, to make sure we get the maximum efficiency out of the system we're putting in for the cost that the customer's kind of looking to have. And essentially, there's a rule of thumb for if you wanted to see roughly what the size upsizing of the radiator would be, but we're fully calculating it on our heat loss tools. And it's just to give you a bit of a flavour as to why we would recommend radiators, why we can't just chuck it onto your existing system. We could with the high temperature unit, but again, we have to provide you with a low temperature design, and your running costs are going to be a lot higher if you're trying to run your heat pump at higher temperatures. And the other thing to point out, I'm talking about the temperature of the water in your radiators. This isn't the temperature in your room. Your room is going to be 21 degrees, kind of regardless of what we do with going on. That's just kind of dictated by the size of radiators and how much temperature we're putting into the radiators. So again, quite a confusing topic, but happy to take any questions on it as and when they come up.
So here we've got some more pictures of some recent installs that we've done. The external pictures, obviously, of the heat pump themselves. I think one of the big drawbacks reservations that people have when they think about having a heat pump, the first thing that comes to mind is, are they going to annoy my neighbours, or the noise? What's it going to affect? Like, am I going to start kicking off with my neighbours? Mine being placed in the back garden, I can't hear it when I'm inside. We've all got double glazed windows now. You really can't hear it from when you're inside. If you've got your windows open, it's probably going to be warm enough for you not to have your heating on, or your heating not coming on because it's nice and warm. Again, you're not going to hear it. One of the things that both Max and myself actually say to people when they have concerns about this is, if I was to stand sort of 2 or 3 meters away from my heat pump when it's running, my neighbour has one of the big square flues, so one of the older style looking flues on a boiler from sort of 10-15 years ago, and that's probably about 10-15 meters away from my heat pump. And if you stand, like I said, about 2 meters away from my heat pump, you can hear that boiler flue over the heat pump straight away. No one has any concerns about having a ghastly green oil tank in their back garden. They always think, oh no, where am I going to put this heat pump, even though they've been living with this oil tank for the past however many years. And the same with an oil boiler. Majority of them being placed outside, people don't drive past their house and think, oh god, look at that horrible oil boiler stuck outside the front of their house. So these things have just got some bad press, but they work fantastically well. It is just a boiler that is sited outside.
Yeah, thanks, Ben. The noise is an interesting one, actually. So, of course, we'd say this, we work for Good Energy, but we used to, Ben, you'll remember this, years ago, we used to install Samsung heat pumps, actually. Great units, worked really well. But when we first picked up these Midea R32 units and we ran one, like Ben and I were genuinely gobsmacked at how quiet it was compared to even the Samsung units that we were putting in. So, of course, we'd say that, we install them and sell them. But no, genuinely, I've got one here. It's outside the front of my property. I think it's about 1.2 meters from my neighbour's window. They've never even noticed it or commented on it. And to kind of attest to what Ben says there, my heat pump's at the front of my house, kind of on the back of my garage. Got an alleyway down beside my next door neighbour's house there. They've got a boiler flue sticking out about halfway down, so maybe about 8 meters from down the side of the property. If my heat pump is on and their boiler's on, I can hear their boiler flue over my heat pump. It's certainly with these units, the noise is out there, but you don't have to take our word for it. I think there's a great video if you look on YouTube about these units being so quiet you can hear a pin drop. I think there is a video of another installer stood in front of one running and he does drop the pin on, and you can absolutely hear it. Like it is interesting how quiet they are. Yes, it's a great technology, and they do work. There's plenty of I think press out there now that's showing that these units do work really well, and plenty of available places to find information as well. But you can also read our reviews on Which. I think we got our latest review came in today, actually, which again was another nice 5-star one from one of our customers. And yeah, everyone kind of attests to the same thing. Ben and the team do a great job installing, do a really professional job. You can see kind of some of the pipe work going behind the units there. And yeah, I mean, it's a heating system. It works. To be honest, we want it to be as boring as possible. We want you to just kind of turn your thermostat on. I want it to be 21 degrees in here, and you never think about it again. So that's the gist there with the installations. Cool. I think that's it in terms of heat pump specific bits. It's just another thing to point out. If you did get a heat pump from us or anywhere else, to be honest, as Good Energy, we do offer heat pump tariffs for our customers and also EV tariffs. I'm on the EV tariff myself only because I signed up to that before our heat pump tariff was available. But essentially what this allows you to do is we have either with the EV tariff or the heat pump tariff, there are 5 or 7 hours of off-peak electricity, depending on the tariff you're on. And what we can do is work with you to make sure that your heat pump is running at hotter temperatures or longer, or doing your hot water, for example, at these particular times. And it's really making the most of your system and what goes on in terms of running cost. My system, actually, I sacrifice a bit of efficiency because I run my hot water really hot overnight on the EV tariff because I've got 5 hours of cheap electric. But I take my cylinder right up to 55 degrees overnight, thrash it at night as long as possible to get it as hot as possible, because I'm paying whatever it is, 7 or 8 pence a kilowatt hour for electricity at night, and then during the day, doing that same thing would cost me 23 pence a kilowatt hour. So you can really make the most of these tariffs using a heat pump, or if you've got a car to charge or a battery that goes with it or anything like that. Again, solar and batteries go really well with heat pumps, and you can again charge that device and use it with your heating system if you've got electrified heat. So yeah, good call out there is that there are tariffs that would work really well with your heat pumps, and our team are really well versed, and we've got really great instructions to help you make the most of these tariffs as well. Cool. Lizzie, I think you've got a closing gambit, have you?
Yeah, thank you very much, both of you. Obviously, thank you for going through that in a bit more detail. There is still the Q&A option that you can see on your screen, so please feel free to ask any questions. We did ask for questions beforehand, so what we're going to do is just run through some of those questions that you kindly sent through to us before the webinar, and hopefully try and give you the answers that you're looking for.
Lizzie, just before we jump into those, sorry, I think if you're driving the slide, if you just go back one, I think we've just missed one on warranties, just an important point to cover. So we spoke about the efficiency that we have, the carbon savings compared to a gas boiler there. I mean, they speak for itself, 65%. What I would say is if you couple this with a Good Energy tariff, which is 100% renewable, your heating and hot water overnight will go to kind of zero emissions if your electricity supplied from us is Good Energy. But something else to point out there is the Midea heat pumps themselves come with a 10-year warranty. So as long as the unit's serviced by ourselves or by Midea, the manufacturer, they cover parts up to 10 years with these heat pumps. And I think mine's been in 4 years now, no issues with mine. But when we have had something out of the box wrong with a heat pump, the parts are dispatched really quickly, and we get that sorted with generally no issues. And just in terms of how we are, I think, regulated and who looks after if you've got a dispute with us or any installer or anything like that, we're certified by MCS, which is a requirement if you want to unlock things like the boiler upgrade scheme grant. We're Which Trusted Trader recommended and accredited. Again, you can go on there, you can find us, look at our reviews, you can see our feedback there. And Good Energy, having 25 years of experience in the renewable space across all industries, solar, energy as well. So some really kind of good kind of accreditations to the company, and a lot of routes for I guess customers to keep us in check if something we did wasn't satisfactory. There's a lot of ways for customers to hold us to account there. We mentioned the sound for the heat pumps as well, but the other big call out that we didn't cover at all here is one of our USPs is we've got a really great monitoring system with our heat pumps, in that we spoke about the temperature in your radiators, tweaks, settings. Somebody might accidentally change something on the control, or something might not quite be working right. We can see kind of all aspects of the heat pump operation through our online monitoring. We can even change settings remotely. So, if there's something going on, a lot of the time, I think a good 70-80% of the time, Ben and the guys can sort something without having to go to site. So we can help you out very quickly across any hours of the day with short notice with any changes or tweaks that you want to make. Hot water might have accidentally been knocked off and you're not sure how to turn it back on. We can turn it back on with a click click of a button for you. And again, you'd have seen through the pictures there, but we don't do, I think Ben said it earlier, we don't do the kind of cookie cutter approach that a lot of the other companies do. I know if you went to the likes of Octopus for a quote, they wouldn't touch microbore pipe work, or they'd need you to do a lot of work before the heat pump installation could go ahead. We like to take on pretty much any property, and if there's a way to get a heat pump in there, we're willing to take on the design and the work there to make sure that we can do it and at least offer a solution. So for that, we do kind of bespoke designs for everybody's properties, and we will always kind of make the design work with you, not just present something to you and say, here you go, this is what you're going to have. It's always like, okay, what's your motivation? You know, is it running costs? Is it capital or initial installation costs? Is it hot water? You know, we'll always work with you to make a system that's right for you and your home as well. Oh, sorry, Lizzie, I jumped right in.
That's
there,
all right, no problem at all.
Yeah,
one of the things to also point out as well with the warranty. So there's a 10-year warranty. You need to have a yearly service to maintain that warranty. We're currently offering 2 years free servicing at the moment, which covers the first 3 years of the heat pump's life. So that's again a really great saving that we've got on offer to our customers as well, which is worth pointing out. So question time then. So one, I'll go, if I start with Max, one for you. So what do heat pumps require, or why do heat pumps require free space around them?
Yeah, really good question there. So at the start of the call, I was talking about how heat pumps work, and basically they take air and they take the energy from the air across this refrigerant, and they blow it out. They blow this, if you like, chilled air out the front of the heat pump unit. The space around the heat pump is just to allow the airflow. If you box the heat pump in, it would gradually get the air colder and colder, and it couldn't kind of disperse that air and bring, if you like, fresh, warmer air to remove the energy from. So the clearance around a heat pump just allows that airflow to continue replenishing the refrigerant inside and delivering kind of hot water to your radiators and your cylinder. You could, in theory, you could not have that clearance, but what you would see is the efficiency of your system would go down, kind of the longer it's running and the more cold air it's pulling across itself. It's much in the way that on a hot summer's day, your heat pump's going to be cruising at 600-700% efficiency because the air's really hot. On winter days, it'll probably be trundling along at 300 or so because the air's colder. If it can't get rid of that colder air, it's just going to make, if you like, a microclimate around itself, and it's going to have colder air around the heat pump, which is a negative impact on your efficiency.
Thank you. Next question for Ben. So what sort of housing for a heat pump is acceptable?
Yeah, so I suppose this just is a carry on from what Max has said. You know, if you was to search sort of heat pump housing online, what you'd probably see is some sort of slatted wooden boxes that can actually, you know, create a different appearance of the heat pump. What we do advise people is, you know, if you are going to have one of these fitted, make sure that they are heat pump specific. Don't go, you know, going down to your local DIY store and start designing one out of trellis or anything like that. As Max said, if you start to box these units in without giving them the adequate airflow, that's when the efficiency starts to drop. There are lots of manufacturers out there, Pump House being one, you know, that do the slatted design, and all of these, as much as it just looks like a bit of garden trellis, they are designed to give that adequate airflow across the unit.
Amazing, thank you. Max, so customers asked, I've heard stories of people having to remove heat pumps in the past because they couldn't generate enough heat or were prohibitively expensive to run. Has the technology moved on in the meantime? Can you be confident after doing a survey that this won't happen for me?
Yeah, good question, and something we hear a lot, actually. You see a lot of kind of yeah, there's the odd story that pops up every so often. You know, my heat pump's costing me whatever, £50,000 a year or something like that. I would say almost, Ben, hopefully you'll attest to this, probably 90+% of issues like this are down to poor design and poor installation of heat pumps. Usually a lot of them on different schemes, you know, eco schemes and things like that, where frankly people try and do the install as cheap as possible because they get to keep the leftover funds, basically. So yes, I've seen those stories, and what I would say is the heat pumps themselves, there is no scenario where a heat pump doesn't work if it is installed and designed properly. Again, they've been around for decades in buildings, public spaces, libraries, things like that for decades. The way we know that our heat pumps work is, I mean, several fronts there. We're accredited by all of kind of the main bodies that control access to the granding. We're obliged to give you kind of a minimum level of efficiency of 280%. What you've seen, even with the complex installs we do, we go way above the 280% as an average. And we are held to task by our accreditations in such that if we are telling you as a customer, your room's going to be 21 degrees and you're only getting 18 degrees, you can absolutely go to our regulators and say, these guys have sold me a duff install. We are obliged to give you the temperatures we said we would. What I would say is that the efficiency, it literally depends on how hot the air and things like that is. So on a particularly cold year, it might be a little bit more than usual, but then on a hot year, you'll make it back. But again, we have very satisfied customers. Our designs work very well, and the monitoring that we have means that if you are seeing something that you feel uncomfortable with, or the costs are really out of whack, we can jump on your monitoring system. We can actually, we can see this issue, and we can diagnose things like flow issues or things that would be the usual suspects where efficiency or something like that is below average. But again, you can absolutely hold us to task with the regulators if something has been sold to you as a complete missell. Again, you can go, it's not just us, you can go to any regulating body for any heat pump installer and hold them to task for that. We have a workmanship warranty for 2 years after the installation is commissioned. So again, if a room's not warm, Ben and the guys will be back out to it to make sure it's as sold for any time between the install and 2 years as well. So it won't happen to you if you buy a Good Energy heat pump, I can assure you of that.
I think just to add to that, one thing I always say when I'm going through the handover period, sort of the handover with a customer, is we're not in the business of just installing heat pumps and running away. We want to be there for the life of the heat pump. We want to be the service provider that comes out and gives you the yearly service on that heat pump. So we want to make sure, one, that it's been designed well, 2, that it's been installed properly, and like I say, 3, we want to be your trusted partner to go and service that heat pump throughout its life as well.
Yeah, and frankly, we want you to go and tell your friends and family that heat pumps are great, and they should get one as well, obviously. So,
absolutely. Yes. Fab, thank you. So another one for Ben. So if I have a heat pump installed now, as we head into warmer weather, will Good Energy return to my property as colder weather sets in, or can you make any appropriate alterations remotely? Before you answer, there's another question which is quite similar, so hopefully you can answer both at the same time. So they've asked that if a heat pump design is set to, say, for instance, -2 degrees outside, when it's warmer, does this allow you to lower the flow temperature to get more efficiency? So they're similar but for different times of year.
So the answer relates to the same thing. As Max said, we've got this amazing platform, our monitoring platform that we use. To answer the first one, if you're having a heat pump installed as we go into warmer weather, what the guys or myself, whoever installs your heat pump, would do is at the end of that, when we're commissioning, we'd go around and balance all your radiators. So what we're doing when we're balancing radiators is we're making sure that they warm up at a similar temperature to each other. We don't want one room heating up really quickly and then the last on the line taking ages to heat up, So we carry out that balancing and the commissioning of the system the same as we would any time of the year. What we can do is we can monitor and see the performance of that heat pump at any given time. So if you give us a call as we're going into winter, and to go into the second part of that question, Lizzie, you think that perhaps the heating curve isn't quite aggressive enough, or the flip reverse of that, we do get people, and myself and Max included, that sort of make the weather compensation slightly less aggressive. So we can make all of these different changes completely remotely without the need to send someone to your house. That being said, if you call us up and you say that you don't think, like Max has previously said, if you don't think it's performing as it should, in very, very small cases, we'd be more than happy to come back out and get that system 100%. But the bottom line is, if we install it any time of the year, it's going to be commissioned to a very high standard. We can remotely monitor it, and if we don't think it's achieving the sort of performance that we believe it should be, then we'll be straight out to sort that out.
Ben, it's probably just worth explaining. We touched there on weather compensation, weather curves. Probably just worth explaining what that is and how that would help this question.
Definitely. So I think when you look back at the R32 versus the R290 model, when we're talking about flow temperatures, what we're talking about is the maximum flow temperature that heat pump can achieve. Now, under no circumstances, it doesn't matter who installs your heat pump, should they just be setting it to a constant flow temperature. It's terrible for the heat pump, it's terrible for your pocket, and it just shouldn't be done. The way a heat pump needs to be set up is on something called a weather compensation curve. And what that means is at any given time throughout the year, the flow temperature or the water temperature of that water running through your radiators is going to be different depending on the temperature outside. So the way that we plot our weather compensation curves, and like I say, these are just the standard one that we put on, is we can change it. But the standard one is, if you imagine, you've got an X and Y axis. Across one, you've got your external temperature, ranging from -2 to +15. And then on the other axis, you've got your flow temperature, which ranges from 37 degrees flow temperature. So that would be at 15 degrees outside, all the way up to your design temperature. So, if you're an R32, it's going to be somewhere between 45 and 55. And if you're talking that higher flow temperature from an R290, then that's going to be sort of 60, 65. And then depending on what that temperature is outside, that would give you your flow temperature to your radiators. So, if it was 10 degrees day outside, let's say, what the average heat pump would probably be doing is around 40 degrees through your radiators. So that's the way that we get them the most efficient. It doesn't need to be kicking out its maximum heat if it's, a nice spring day outside. It's a terrible way to destroy the efficiency of the heat pump.
Yeah, thanks, Ben. Yeah, it's just really simple. Day here in Nottingham where I live, it's about 15 degrees outside. On the coldest winter days, my heat pump would be doing 50 degrees. On a day like today, if I go and touch my radiators, they probably won't even feel warm. It'll be about 30 degrees or something like that. And so the question there about how do we, what do we do when colder weather sets in? If we've done our job properly, I can't think of an instance where we wouldn't have put a weather compensation curve on ever, to be honest. But as it gets colder outside, your temperature of your radiators will increase. And what that does is, I talked earlier on about, we measure the heat loss of this room and how much energy do we have to put in to maintain 21 degrees inside. Well, the warmer it gets outside, the less energy we have to put in to keep that temperature. And it's just basically allowing the heat pump to intelligently control its temperatures there to maintain that efficiency and that comfort for you.
Amazing, thank you. So we have come to the end of our webinar. However, there are still some more questions. So if you both are happy to stay on to answer those.
Yeah, no problem for me.
Yeah, lovely. And obviously everyone else, feel free. So the next question, so for Max, most efficient internal setup, would it be a single zone or single zone versus multi-zone, TRVs or not, plus use and impact of buffers or volumizers?
Okay, yeah, so a lot to unpack in that question. I would say it feels like a catchphrase when I do these podcasts on renewable heating stuff, renewable heating hub and things like that. But it depends. It really depends on the setup of your property. The way I can talk about what I have set up and how a lot of our installs are set up. But generally, what we like to do is heat the house as one and keep it warm as one. So by that, I mean one zone. Some people like to have different temperatures upstairs and downstairs at different times of day. So you might heat an upstairs and downstairs in terms of two zones. And some people might have a dog leg of the house, and that part never gets kind of lived in unless there's guests, so you can turn that on and off. Our design team and our surveyors will kind of discuss these things with you, as will Lizzie and the guys on the phone there, and we'll figure out what is suitable for your property. But the most efficient way to do it is to heat the house as one system, one zone. You might have rooms cooler on their TRVs in the rooms. But in my scenario, in my house, I can only speak from my personal experience. I've got underfloor for a part of the downstairs, radiators everywhere else. My house is always on as one zone. All of my TRVs are on. If you think about, one big block being your house, if you turn half the radiators off in that, you've only got half of the heat generation ability to heat that house up. And I'm sat in a room here. If that room next to me was 20 degrees colder than this room would be losing heat into that room. Therefore, you'd lose efficiency. So we try and heat the house as one. But that said, we can make it work for whatever your requirements are. And then when we talk there about buffers and volumizers, so buffers generally isn't something we use. There are certain scenarios you might want to use a buffer. Volumizers, yes, we have used volumizers in the past. This is generally with underfloor heating. They're quite different things. What a buffer does is it allows you to do something over here with a heat pump on one circuit, and it, if you like, detaches the house from that heat pump circuit. and the house can do its own thing over here. The reason is heat pump needs water to move around really fast. Heating system, not so much. So it just allows you to have two different things going on there. But we can do that. We can do what's called direct pipe. So the heat pump's teed straight into your radiators. Volumizers is a little bit different. So a lot of heat pumps in the winter, when it gets really cold and they might kind of frost up, they need to defrost themselves to start working again. They need to draw energy from the water to kind of defrost, and then they'll start working again. You need a volume of water to do that. It's in all the manufacturer instructions. You need a minimum of, say, 40 litres of water for the heat pump to be able to do that. So if you've got underfloor heating and we don't have 40 litres in it, because there's not a lot of water in underfloor heating, we might have to chuck in something called a volumizer, which in simple terms is a big bucket of water, got a pipe that goes in one side and comes out the other, and it just adds volume to that heating circuit to allow the heat pump to do things like defrost. So again, to go back to the start of my answer there, it depends on what your particular needs are for your property. And Alex and the guys in the design team, really kind of clever guys, a lot of heating accreditation in that team, looking and calculating and figuring out what works best for you and your property, and what's going to be best for that particular setup and scenario.
Amazing, thank you. A few more questions. So I've got one, and I think I can probably tie in two together. So Ben, so someone is getting a battery EV charger and heat pump installed. Would they need to move from single phase to 3-phase power? But also to sort of piggyback on that, what's the integration like with solar panels and a battery? Is there a fully integrated package?
Yeah, so I think it's a good question for me. Actually, I've got a 12 kilowatt Midea heat pump. I've got a EV charger, and I've also got 5 kilowatts of battery storage. So I've got real experience with this, and I have single phase. I've got a 100 amp main fuse, which is the maximum that the DNO will give you on a single phase. What we do when we come to do a survey is we will take what's called a maximum demand reading. It might seem really strange if any of you have had it done in your property. The surveyors will run around, ask you to put on various bits of electronic equipment, and then we put a clamp around your incoming tails for the electricity, and we'll take a reading, and then we apply to the DNO, and that's the district network operator, which is the people that own all the cables in the floor wherever, whatever area you're living in. And we send all those readings off, and they'll tell us if they're happy with the current demand in your area. What I would say is, it seems like really electrical heavy household. Things are getting so smart now. So the EV chargers that we install, they are actually what are called a load rated. So there's a little clamp that will run all the way back to your meter tails. And if it thinks that it's starting to pull anywhere near to the max demand that your house could start to pull, it will range rate itself down. So these technologies are all becoming intertwined. We know that we're going to have to become, more electrical heavy in our household. So these designs and different products are becoming a lot smarter to enable them to work together. That being said, obviously with the second part of that question, Lizzie, is a single use package that we've got. Currently, we don't have anything, where they all talk to each other seamlessly. That being said, that I'm sure that within time that will come out, especially now that we're doing, all of this solar and heat together. What we're really, really good at, though, is when the guys are commissioning your system, they'll give you, a good walkthrough, and they'll talk to you about your usage and what you may be thinking of having installed, or perhaps you've already got battery and solar PV or an EV charger. And what we'll do is we'll start to, perhaps time certain things so that we can get the best out of your system. Like Max said, if you've got a really good time of use tariff, we'll set your hot water up to come on and superheat overnight. If you've got a large solar PV array on your roof, perhaps we'll time your hot water to be from the hours of 12 until 2 in the afternoon, when you're going to be drawing the maximum amount of PV. We can sort of try and give you as good as we can in the commissioning process, but there's not that one app fits all, unfortunately, at the moment.
It's a good answer, that, actually, Ben. I recently spoke to a big solar manufacturer who's trying to make a control. It's not that we don't offer it; the control just doesn't exist that talks to all kit and equipment at the moment. But it's a funny one for me. So I've got, similar to Ben, solar, battery, heat pump, EV charger. I wouldn't want something to take control of mine because I'm on an EV tariff, so I run all my hot water and everything overnight. I'm charging my battery overnight. When my solar's charging, or when the sun's out during the day, I actually don't want to use my my energy, because I buy my energy at like 7p a unit overnight, I can sell it back to the grid at 15p. So I actually just want all of my solar to go to the grid, because the proof's in the pudding. What we're on the 24th of April. So far this month, I'm in profit on my energy bill with all of those things. That's my case. It's not going to be that way for everybody, but running a heat pump, EV charger, battery on Good Energy with solar export, I've made money so far this month running all of that. So I don't necessarily think personally I wouldn't want a control doing all that for me, because it takes that away from you. But that's kind of the advice the team can give you as to how to make all these tweaks and make things work for you, and really maximize your personal system in your house.
Absolutely amazing. If we just do one more question, and then any other questions we can email up. We can follow up with an email with the recording as well. So I'm probably okay to answer this one. I'm probably the best place for it. So, well, there's two really that I can answer together. So what's the time frame to completion of an installation from survey to install? And then can you run through the process if we decide to place an order? Will you then arrange a visit and work with us to recommend and finalise the best air source heat pump design for the property? So firstly, from survey to installation, we can work as quickly or as slowly as you'd like us to. So typically, once we've had the initial conversation with you, we can book a survey within the next sort of 72 hours, typically across the teams. If you don't need that, if you want it slower, then fine, but that's the sort of availability. We had a customer last week that myself, Max and Ben were dealing with, who came into us 3 weeks ago. Their boiler had broken, they were in desperate need of a heat pump, and we were able to organise everything through a 3-week period. So we can be very flexible within that if our diaries allow it to, but we can work with you to ensure that you're getting the service and the install in the timeframes that you're looking for. If you'd like to go through with an order, what does that look like? So once we've confirmed the design, we've got your energy performance up to date, and we can confirm that we're happy with it all, we would then request for a couple of forms of ID from you. Once we have that, we'd send out the contract for signature, and that's done via email, via e-sign, so it's through Zoho Sign. Once that's been signed, the person that you've been dealing with, so whether it's myself, Harry, or Uday, would then give your details over to our operations team. So you'd be working with Emma and Brad, and they would send out your invoicing. So you'd pay for your invoicing. So there's three different stages. So you've got your initial invoice, your booking stage payment, and then your completion. Emma would organise all of that for you and send that through to you. Once you're ready to book in for installation, we would then send through that booking stage payment, and then on completion of the installation, you would pay any remaining balance. In regards to whether or not we come out to the property beforehand, if required, we will do. However, once the contracts have all been signed, Alex and our design team will go through the final design for you. They'll triple check everything, discuss everything with you, send through all of the design notes to make sure that everything is clear and we're confirmed. If required, we will come out to you, but it's not always necessarily needed before we come out to do the installation. But anything else any of you guys want to add?
I was just going to say, Ben, what are we looking like for install availability at the minute? I think it's about second week in June is the next slots we've got available at the moment, right?
Yeah, all depending on location. I think the main thing that I want to add is, every one of the engineers that's in my team, they want to treat your house with the utmost respect. We treat everyone's houses as if they were our own. The guys are so good at making sure all the protection is down, really making sure that your house is well looked after and put back exactly the way we found it when we entered the property, which I really pride myself on when I go to installations, travel around, and the great level of detail that the guys go through to ensure that, one, the customer's having a really good install, but also, the pride that the guys take in their work, and it's really nice to see.
Great. Thanks, Ben. I don't know if there's any kind of urgent. I can only see one question in the Q&A, but I'm happy to just take that one really quick that I could see in there, which is, I think somebody's asked there, for a unit installed in the house, can it be fitted to the wall, not on the floor? And if no, what disadvantage of installing it in front of the garage and outside the unit, the back garden? So a couple of bits to that. Yes, the units can go on the wall. They absolutely can. But what I would say is, some of these, I think the bigger units, the 12 and 16, are what, Ben? You lift these on a regular basis, 160 kilos, 140 kilos?
150 kilos, yeah.
So, yeah, you can wall mount them, absolutely. But we strongly recommend you consult a structural engineer about basically hanging off of 2 brackets, 160 kilos onto a wall, so that it can take the weight. But again, there's no detriment to performance having it installed on the floor. I think just trying to decipher the end of that question there, but the disadvantage of installing in front of a garage outside in the back garden, I don't really follow that one. But I think all I would say is whether it's on the floor or on the wall, it's no real difference to performance. I think what would be a bigger impact is how far or how close to the house that is. The further the water's got to run through pipes, just natural physics, the more heat it's going to lose over that time, and therefore how a little bit more energy has got to be put in to compensate for that the further the heat pump gets away from the house.
I think just to add on that as well, pros and cons of it being high up or low down, you know, if it, heaven forbid anything went wrong, or, you know, you're having your yearly service, accessibility to the heat pump is very important. You know, it may affect response time, trying to get, you know, scaffolding up or so on, or the ease of changing a part, or even just the ease of having it serviced yearly. So once the servicing, the pre-servicing is complete, you know, you might actually find an engineer out there that would want to charge a surplus to actually go up on a roof or get scaffolding to actually service that unit as well.
Yeah, that's a good point. If we need scaffolding to put the unit up on the wall in the first place, then the lads are going to need scaffolding to service it every year as well, which just adds to cost and things like that. So it can be done. It's just, you know, we got to be aware of the requirements of that.
Yeah, absolutely. Brilliant. Well, thank you so much. And thank you everyone for joining us. We will send a follow-up email with any questions answered that we haven't been able to do today, and also a recording so that you can reference back. Please feel free to contact anyone within the team that you're dealing with any other questions, and we'll be more than happy to answer those as well. But we hope you have a lovely evening, and thank you for joining us.
Thank you very much, everyone.
Cheers.